All right, we're going to start today. We're going to talk about vectors. Vectors, as we talked about, indicate two things, magnitude and direction. We usually draw them with cute little arrows, and they usually start with what we call the initial point, and they go to the terminal point. In this case, 2 centimeters would be our magnitude, 55 degrees would be our direction. If you had two vectors in the same direction, add them up, call it 4 centimeters, and you draw it like so. If they were in opposite directions, you would subtract them. If they're at right angles to each other, the resultant vector can be found using the Pythagorean theorem. So in this case, we have a 3, 4, 5 triangle. You'd also want to find your angle. I didn't do that in this case. So if we snuck a peek at vectors that weren't perpendicular, you use what we call the parallelogram method. So you'd turn them into a parallelogram, and the diagonal of the parallelogram is called the resultant vector. And I'll show you how to solve those as we go. So let's say we had a 2 centimeter vector at a 55 degree angle. That means it's going to the right and it's going up. So we'd want to actually break that vector down into its horizontal and vertical component. You can use a little trig. Horizontally would be 2 cosine of 55. Vertically would be 2 sine of 55, using what we know about trig. If you sneak a peek at number 1 on the back, you've got vector x. I measured it for you. It's 2 centimeters. The angle is 55 degrees. If you look at y and measure that, it's 3 centimeters and the angle is 140. Well, in question number 4, I think they asked you to actually add those up. To do that is going to require a little bit of work. So you want to break down each vector into its horizontal and vertical components. So I'll spare you the bloody details, but numerically you can figure out what those are using cosine and the sine of the angles. And you can confirm with your calculator. Well, now, if you look, the 2 horizontal vectors, the bigger one is the one on the right, and that's to the left, so it wins by 1.14. The 2 up vectors are both going up, so you add those together. Use the Pythagorean theorem. You have a left and you have an up. Use the Pythagorean theorem, and then you can use your inverse trig functions, inverse tangent, opposite over adjacent, to figure out your angle. Your angle is 72.3 in that case. All right, so skipping ahead, you can read through 8.5 notes, but I'd like to draw attention to number 1 on the 8.5. You've got a 97 Newton force and a 38 Newton force at 70 degrees. Well, you're going to have to break down, and I'd break down the 38 Newton one into its horizontal and vertical components, just like we did in the last example. The horizontal component would be 38 cosine of 70. The vertical would be 38 sine of 70. Now you've got 2 horizontal ones that you could add together. So that'd be the 97 plus the whatever the horizontal component of the 38 Newton was. And then you have an upward component of 35.7. Use the Pythagorean theorem. Use the inverse tangent, and you can figure out the angle. Then you've got your magnitude and your direction. Whew. Lots going on there.